Well, I got a little bit of reverse engineering done on my SAS source destination selector, whatever it is, overnight, and came up with some interesting stuff. I actually figured out where everything goes and what memory region everything lies in. It doesn't have separate I/O space, so the I/O is in the memory, the 64K address space. Different chips have different select lines at different addresses, and of course the ROM is at the top, 32K. RAM is from 24K to 32K. Serial 1 is 16K to 24K. Serial 2 takes up 8K to 16, and display from the base of the memory up to 8K. Now it doesn't actually use all that space. It only uses a fraction of that space. They're mainly just using it for a select and a couple of data lines and stuff to go through to whatever it needs to go to. There's actually 2 serial ports on this thing. One of the chips is missing. Hang on, let me go get the doohickey. Oh, here it is. Yeah. Ouch. Okay. So, in this device, there are 2 spots for serial doohickeys. A 6350 Hitachi, which is the same as the 6850 apparently. I don't know. That has to do with the 6303 processor or what. It's got, I think that's a 32K ROM. That's at the top of the address, but it's a 27C256. Yeah, pretty sure that's 32K. And that's like an 8K RAM. This is serial 1, this is serial 2. Now, these 2 open sockets over here are actually for another display. I saw the larger units had 2 displays, but this one only had 1. I should have got some of those too. Shoot, because now they all went to junk. Oh well. Anyways, so these devices over here control the data lines that go to the display and from, I should say, because it's got buttons and a little spinny thingy too. So one of these, I forget which one. I think it's, oh, this one is. They're using this for the inputs, and these 2 for the outputs, and I forget what this one is, but I think it's got something to do with it too. You've got a 74HC14, a 00, a 138, and a 139 here. These are the address decoding logic and stuff. They also managed to do some kind of funky logic for the read-write and the RAM, and I forget what else. Serial enable, and it's a bunch of stuff. But I'm getting there. I'm thinking this is a Maxim device. This is probably for the serial port. It's an RS485, I think. And I'm pretty sure there's another space for another one here or here. And you probably have to add capacitors and resistors and junk to it to make it work. But so far I've gotten out almost all the select lines for everything. Well, U9, U19, U12, which doesn't exist. U11 probably has another select line too. I'm guessing that's probably pin 12 of the 74LS138. But that's about it. Here's the thing again. Not too descriptive, but it's a start. And I was able to fill an entire EEPROM with no ops and see that it flashes the lights on the front panel. And it does something weird with the display, but I can't. Well, now that I know the address of the display, I can write to it. Oh, the display. Display has another thing. This is a commercially available display. It's a smart display. It's how many characters? 1, 2, 4, 5, 8 character red LED display. And this has got a bunch of pins going to it, a bunch of signals. 8 data lines, you can see there. And it's got some addressing logic and some other stuff. So somehow you've got to clock something onto one of these chips and something onto the next one. and that makes all these lines light up. All these lines have what you want on them at the same time. And over here, pretty much everything on this is input. So the little knob here, the big old button over here, these two buttons here, there's LEDs in each one of these little buttons too. And I've made those blink before with just a no op. So it's probably just, I'm pretty sure those are just sensitive to address. They're connected to address, whatever. Anyways, they're on the address bus such that I don't think you have to write to the data lines to get them to turn on or off. Although I'm pretty sure you do have to scan them. So ultimately the goal with this, I've got 3 of these. I wish I'd have got a bunch more now because they're kind of cool. They're nice boxes too. 1U rack mount boxes. But eventually what I want to do is put an Ethernet port here instead of this DB9 RS485 serial, and use these to control my Axia nodes. Yes, using SAS ANC-8 alpha output controller to control my Axia nodes. I can do it because I reverse engineered it. And you can do anything with anything if you screw with it long enough. And remember, how's it go? It's not screwing around, it's science if you write it down. See you later.